This is the first in a series of videos on sequences in series, and in this one we introduce the idea of a sequence. So without getting into a formal definition, let me just give you some examples of sequences. Here's an example. Let's do 5, 7, 9, 11, 13. Oftentimes at that point a sequence would stop and you just have 3 dots, kind of ellipse. And what we mean here is that this pattern continues. If you notice here that you increase by 2, by 2, by 2, by 2. So a sequence here is just a series of numbers, sometimes with a discernible pattern. Let's give an example. Another example would be 6, 12, 24, 48. And again, we have a series of numbers, has a certain order, each one has a certain amount. Here's another example. 4, 7, 13, 22. Here the pattern's not as obvious, but if you look, the difference between 4 and 7 is 3. The difference between 7 and 13 is 6. The difference between 13 and 22 is 9. You might infer then that the difference here would be 12, and that would be 34. You're never 100% sure what's going to be the next number in a sequence, but oftentimes you are. So let's look at a given sequence, right? So let's look at this sequence right here. 10, 13, 16, 19. Nothing particularly complicated about this, but if you notice this in the sequence, each element has 2 different attributes. It has a position or an order, and it has a quantity. So for example, we say 10, this first term here is both the first term, this is the second term, the third term, and the fourth term. So this 10 both has a quantity of 10 and a place. It's the first in this series, in this sequence. This 13 has a place, the second term, and a quantity, 13. The next one has a place and a quantity. And that's basically how you define a sequence. And the notation that we use is we'll often use a letter. For example, A is equal to 10, 13, 16, 19, 22, 25. And we'll call this, if this is sequence A, we call this A1. A with a little 1 subscript. This is A2. This is A3. That's A4. A5. A6. So the way we read that is A5 is the 5th term of sequence A, and it's equal to the quantity 22. That's the idea of a sequence. We often use A, we don't have to. You could have another sequence, we could call it B. B is equal to, let's do this one, let's do 10, 20, 40, 80, 160. So B3 would be 40. That means the third term of sequence B is 40. If we said B17, that means the 17th term of sequence B. And sequences can have fairly easy or fairly complicated patterns. The first thing we sequence is we need another definition. We want the term, the definition of a finite sequence and an infinite sequence. And the definition is pretty easy. A finite sequence ends, and an infinite sequence doesn't end. So for example, if you had a finite sequence, you could have a finite sequence 1, 3, 5, 7, 9. If it stops right there, then it's a finite sequence. If it goes 1, 3, 5, 7, 9, dot, 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 that implies that it goes on forever. And since it goes on forever, it's infinite. Now, sometimes we could use the dots in a different way. You could have 1, 3, 5, 7, 9, dot, 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 123. In this case, in fact, it does stop, and we just use the 3 dots to note that we're not going to write it forever. A little more formality here. Let's say again you have a sequence a to the n is equal to 4, 8, 16, 32, 64, dot, dot, dot. And then this is A1, A2, A3, A4, A5. Then in the same way the functions, we call this the domain, and this the range. And though we don't usually necessarily think of it as functions, we can, because what you can do is you can tell me which term it is. So if you want to find the third term has a certain value, in this case is 16. The input here is which term it is in which sequence. The output is the actual quantity value. So here's the key to a sequence. Each element has a position, or you can think about it in an order, and a quantity. And that's the introduction to sequence series. The next thing we'll talk about some other facts.